Okay, in this video, I'm going to teach you my workflow going from Revit to AutoCAD to a laser cutter. So here I have drawn a pavilion that could be used for, let's say, a bus stop, and it has some different angled surfaces to it, some walls, has curtain wall, some benches. When you make your model, at a scale model with a laser cutter, you might be doing a more complicated model, but this one's just to get you a little feel for my workflow here. So getting into it, what I've done first is I right-click and I go to Duplicate View and I say Duplicate. And in this view, I name it 3D for laser or 3D laser. And in my 3D laser view, what I end up doing is setting my scale to what I want my model to be made at. 1/8 inch equals a foot. And then from here, what I do is I click on one roof, and then I hold down Control, I click on one wall, and I click on one floor. And in this model, I don't have that many of these items, but all you need to do is select one of each, and then with the sunglasses, turn on Isolate Category. And this will get rid of all the other clutter that's in your model. This allows us to use the laser cutter to build our model as efficiently as possible here without having all the other objects in the way, like doors and windows and some minute details that maybe you're not planning on cutting the first pass through on the laser cutter. I recommend making your models this way and then adding detail later as smaller, thinner items that you can apply to this. So for example, if I wanted to build the curtain wall that was here, I could go and make that separately out of maybe balsa wood and some plexiglass. So then from there, what I do is I right-click and I duplicate view and I duplicate my laser. And in this copy, I'll name it. So for example, angled wall 1 east. And so what I do is with the view cube, I right-click on it and I say orient to a plane. And I do pick a plane and say OK. And then I select the surface, so this angled surface, for example. So that way I'm looking at it straight on. Now I know that this is the exact size of the wall that I want. If I was looking at it on an angle like this, or like this, I'm sorry, I clicked on the wrong wall. If I was looking at it like this would not be the right size. When it goes to cut out the boundary for this wall, you'll see that it's on an angle. So I need to look at it orthographically or straight on, perpendicular to the surface. So to do that well, once again, right-click on the view cube, orient to a plane, and then pick a plane, say OK, and then make sure you hover on the edge of what you want, pick that plane. And so this is the right one. So this is my angled one wall, and then it's towards the east side. I do the same thing with the floor. I do the same thing with a lot of these items. Now with this angled one east, what I want to do is I want to isolate this one wall here. And you'll see that this other wall coming into it is part of it. And so I need to have part of this wall showing as well. So really what I want to do is isolate the wall category. So I click on the sunglasses and say isolate category. And now I have this wall. And I need to mentally note that I don't want to include this part of this wall, but I do want to include the whole edges and boundaries for this one. I'm going to do the same thing going to my floor. And with the floor, I can say isolate element in this case, since I only have one floor. For my north wall, I need to make sure I find a view. So this is the north wall. This is the very far north one. And in Revit, by default, the back view is the north view. And so here I want to isolate this category as well. And I need to note that this north wall, I want the inner edge here because this other edge belongs to the angled wall. And so I just need to note that mentally, or I could write it down. And so this wall right here, I want to isolate elements. So I want that inner edge. For my roof, I'm going to have two different roofs. So I have roof 1 and roof 2. And I do the same thing. I do right-click on the view cube, orient to a plane, pick a plane, and you get the idea. Now that I have that roof, this one is on a different angle than this one, so I want to isolate this one by itself. So I hit the glasses, and I want to choose Isolate Element. And I want to note that the thickness down here, I don't want this bottom part, so I'm just going to keep the triangular part, that surface right there. And I'll do that in AutoCAD later. And then this view, I do the same thing. I already have it angled, so I'm going to skip showing you that. I'm going to do Isolate Elements. Same thing with the south wall. That's this big one right here. So I just click on the front face of the cube. And then here, I need to isolate the category of walls. And the reason I do that is because part of this angled wall becomes part of this wall here. And so I need to mentally note that in AutoCAD, I'm going to delete out this extra line work down here, and I'm just going to keep this nice surface right here. The west wall, same thing. I need to isolate just this wall, but notice that the two walls that are perpendicular to it are kind of part of its boundary. So I'm going to isolate the category. And I'm just going to remember that I don't want anything above it or inside of this cutout. And then my 3D stays by itself. So that way I can use this, let's say, for a cover sheet later on, or a rendering. And then now I have all my other ones that I know are just for the laser cutter. Then what I do is I create a new sheet. So right click, new sheet. I'm going to choose size E by default. That's fine. It's the largest paper size. And then what I do is I double click into it and edit the family. And in edit family, I delete out the title block that was there. And then I say load into project and close. And I just say yes, save my changes, and that's okay. Save my changes. And so then this comes into the project nice and clean. And then from there, I drag in my views. So here you see in my A102, I have all my views dragged in. And they only take up a little bit of room on the page, so you should be able to fit most of your views on your paper. If you need to make more than one sheet, you can do that. And then once you have all of your views in, we can send this out as a DXF file. So I have all my views. Then I'm going to go up to File. I'm going to say Export. I'm going to do CAD format. I'm going to say DXF. This DXF file we're going to end up bringing into AutoCAD. We're just going to say Next. We're going to say Desktop. And I'm just going to save that as a laser cut file. And say OK. I'm going to say leave the temporarily isolate mode on. This is very important. Otherwise, all the work we just did went away. So we're going to say leave the temporary hide isolate mode on. And then with that, we're going to open up AutoCAD. We're going to go to Open. And we are going to choose a DXF where we saved it. And say Open. And then all this line work is going to come into AutoCAD. It's going to first open the title block that we had in paper space and layout. We're going to click over on the Model tab down here. And in the Model tab, we said we have all this line work. Now we have to clean this up. So if you remember from before, I didn't want these lines here, so I'm going to just delete those. I'm going to use the Line tool, and with OSnap, so I'm going to hit Escape real quick. OSnap, I want to make sure that my OSnaps are on, and I want to make sure that endpoint is checked. That's going to make your life a lot easier. Then I'm going to click on the Line tool. So I'm going to snap. Anytime I see one of those green squares, that means I'm snapping to an endpoint, so I've closed that one off. This one here, I believe I want the inside. So I'm going to do Trim. Select your cutting edge first, hit Enter, and then select the edges that you want to cut, and hit Enter, and then delete out any other lines. Here, I want just the triangle on the inside, so I get to delete out those. It's not completely crucial. I'm going to undo that. It's not completely crucial that you get this perfect, but you might as well. It's a lot easier to make the edits in AutoCAD than to do the edits with your utility knife later. Trim, Enter, select the edges you want to trim, Enter. Now here in this one looks a little crazy. We don't need anything on top. And I'm just going to select these lines here that I know for sure. And then I leave the long ones that I need to trim for last. So Trim, Cutting Edge, Delete. Down here, delete these, delete that. This one here, Trim, Cutting Edge, delete it. And then over here, I'm going to do kind of the same thing. Select all these. We don't need it. We don't need it. Delete it. Delete it. can use it. Okay, now we're going to do trim. Now here's a trick with trim. If you don't know what your cutting edge is, so just select everything, hit enter, and then select the parts that you don't want. That's another way you can do it. Sometimes it's faster that way, sometimes it's slower, so you have to know kind of your project. Now with this, select everything, put it all on layer 0, and then Control-C to copy it. Bring it over into your laser cutter file. Here I have a template file pre-made. Essentially what I've done is I've just scaled up. So this is the size of my laser cutter bed. And then at a half scale, it's doubled. So that way anything I drop in here will be scaled in half when I go to print it in paper space. And then I just kind of scale these up by the same measurement all the way up as the scale indicates. So then that way anything I place in here can be real size, and it's just going to automatically scale. So here I'm pasting in the line work that I brought in from the other CAD file. So Control-C to copy, and then I go over to my template file and I highlight it, Control-V to paste from the other CAD file. So now that I have these in, I'm going to stack these so that way they fit a little bit more square. I call it packing it in. And so then now here that I have it packed, I'm just going to use my move commands, and I'm going to use a 1/8 inch equals a foot scale. And so here you see that I've already dropped in all my pieces for a 1/8 inch equals a foot scale from before. So in this scale, I have my pieces, and I like to place those near the top left corner because that's where I typically set my origin for my laser cutter. And down here it says 1/8 inch equals a foot. That means in this tab at the bottom in my template, 1/8 equals a foot, this paper size is the size of the laser cutter, but anything inside that box has already been scaled down. It's shrunk 1/8 inch equals a foot scale, so a 1:96 scale. It's shrunk down to fit inside that original paper size. So basically this size box is scaled down to fit into this 1:1 full scale box. So it automatically scales it for me. If you want to do a custom scale, what you can do is just bring in your item to AutoCAD, and then you can type in the scale command, pick your base point, and if you know your scale, let's say it's a 1:25, or actually I'm going to do one easier, like a 1:10, so that's going to be 0.1, 1/10. So then I've scaled it down to 1/10, and if I was doing it at 1/10, I can just move it into the 1:1 scale because I've already scaled it. And so here you see that only one of these pieces fits in 1/10 scale, and since I've already scaled it, it goes in the full scale box. If that doesn't make sense, you can make your template file a little bit more straightforward. Then I keep a note, and so there's some commands that we can run. Flatten doesn't always work. If you have a 3D object and you run the command flatten, it works great. It sends it flat into like a 2D object. However, sometimes flatten ruins your drawing. So if I go over to my pieces, since they're already flat, if I highlight them and type in the word flatten and hit enter, they're going to turn really small and go off into a corner. And so if that happens, you know that's not the command for you, and then you can press the undo button. If you have some 3D object that you brought in and you want to flatten it, flatten command works great. The ones I am going to run is overkill, which deletes any overlapping lines, and that stops the laser cutter from cutting excessively, from burning, from taking longer, stops it from smoking. And then p-edit converts them into polylines, and that makes it one continuous path for the laser cutter to follow. It works a little bit faster and more efficient with p-edit. And then from there, we're pretty much good. So I'm going to zoom in here. I have my stuff highlighted. I like to do the explode command first, and then since I have those, then I'm going to run the command overkill. So if there are any overlapping lines, I would say okay. It would tell me if they deleted any. 43 found. It said that there's 43 lines found, but none were duplicated or overlapping, so that means it was good line work. And then I'm going to highlight the whole thing, type in the word p-edit, and then I say multiple. And actually, this is where I highlight everything. Then hit enter. Convert them into polylines, Y for yes, hit enter. And then you just right click and then say enter. And so now that I have this, I need to convert these lines to the laser cutter lines. So I have a setting here for vector cutting, and my layer for vector cutting has these certain properties to it. So my laser cutter needs a line weight of 0.00 millimeters. In Illustrator, it would be like 0.0001 or something like that. But in AutoCAD, laser cutters tend to work at 0.00 millimeter line weight. And my laser cutter will recognize these white lines as black lines when they're in paper space down here in layout. And so it knows to cut black lines with vector cutting, and then it'll do raster engraving. So if I turn anything on this red layer, it'll not cut it, but it'll imprint the image by burning it into the material. So what I do now is on my tab, I have my paper space laid out, and I have my file here. And now I'm ready to save this and then put it on a flash drive or on Google Drive or email it to myself. And then I would bring it over to my desktop computer that's hooked up to my laser cutter, and there I'll run the software for the laser, and that'll be next. Okay, now we are ready to take our drawing from AutoCAD into the laser. So I'm going to go down to my tab here that I have 1/8 inch to 1 foot. And I have my drawing packed nicely into the corner. From here, I go up to print, and this is on the desktop that's hooked up to the laser cutter. And I'm going to just say continue to plot single sheet. And since it's already hooked up to the laser cutter, there's already a print driver in here. So I'm just going to scroll down or up to the one that says Epilogue Engraver. This one is going to come in. It says 100 inch by 100 inch. That's not actually the bed size. And you'll see the way my program works in this example that the laser cutter itself has a drag and drop feature. But a lot of times laser cutter beds, the driver will indicate the exact size of the bed. In our case, we don't need that. My scale is 1:1. That's really important. And then from there, everything else should pretty much be by default. And we just say OK. And now this sends this as a print job. And here we can see that there's an old file in the way. Now here I have my actual item. And if I hold down Shift and use the rotate command, if I hold down Control and use the rotate command, it'll snap it orthographically or at default angles. So I'm holding down Control, and I'm going to pick it in an area that I think fits it well. And then I'm going to go and place this up in the corner so I waste the least amount of material. The worst thing I can do is just place it right in the middle. I'm going to waste a lot of material that way. I also want to avoid any rip. You'll see that this laser cutter is kind of cool because it has a camera. And so it's actually looking at the exact piece of paper. In this case, it's 1/8 inch thick chipboard that's which is like a cardboard that's on the machine. This bed size is 20 inches by 32. But you also see that you can drag out areas to make sure that you don't cut in certain regions. So if I did this, any material or any line work that was over in this dotted area would not actually laser cut. So now that I have my job here, there's some settings over on the right, some power settings that I need to adjust. And so for a 1/8 inch chipboard, what I've found works really well is a power of 50 and a speed of 30 and a frequency of 50. So the speed here is going to be 30. This is on vector, so that means it's going to be cutting. If it was on an engrave, then it would be doing a kind of like an imprint of whatever the line work was. So here I have it on vector. And then from here, I would go to print. Now, before I actually go and print this, I would have to turn on the vent for my laser cutter to make sure it's exhausting all the fumes correctly. And it has air assist, so it's going to help die out any flames. And then from there, I need to also calibrate the bed height, so that way it's focused. And the laser cutter that I have has a little spring-loaded mechanism that you can bump the material to here. So now that we have all that, we're going to press print. And it's going to send this job over to the machine. And then from there, you can press play on the machine, laser cut out your pieces. Here you're going to see the laser cutter in action. It's following the path of the lines, and the camera's catching the progress. Make sure you supervise the machine as it goes, so that way if anything catches on fire, you can hit the big red stop button on it and kill the power. Make sure you open any windows, pull any smoke alarms that you have to do, just in case you have a problem. Everything should come out just fine. I'm going to open up the machine right now. And you can see all the pieces cut laying here on the board now that I've taken away the material. And now I'm going to do an assembly, and I'm going to use my 3D drawing to help me assemble this piece by piece. Don't forget to save and subscribe. If you liked the video, please give it a thumbs up.